Welcome to Physics Made Easy channel, and we have started the topic of photoelectric effect, and I will give you first brief review, and then we shall be coming further. Now, the brief review is first we studied work function. Work function is the energy required for a free electron inside a metal to leave the metal surface. Now, note the word free electron. Free electron, minimum amount of energy required by free electron to just escape from the metal surface is work function. This is different from ionization energy. Ionization energy is the energy required by an electron to get free from the nuclei of an atom. One important point is in modern physics we use the unit electron volt. And 1 electron volt is the kinetic energy gained by an electron while falling through a potential difference of unit volt. 1 electron volt is the kinetic energy gained by an electron when it falls through a potential difference of 1 volt. Now, work function depends upon condition and nature of metal, and also note down the value of the work function. You will be asked to calculate the value of the work function in your numericals. Work function for cesium is 2.14 electron volt. In numericals, or if you have to solve problems even in your MCQs, your work function should never be less than 2.14 electron volt. If it is, then you should check your calculation or your methodology. Another is, if the metal is platinum, for platinum it is maximum 5.65, and if your answer is more than 5.65 electron volt, even then check it. Electron emission. Now, work function, your energy required, your work function can be supplied in different way to an electron. One is by heating, we call it thermionic emission. Another is by applying electric field, we call it field emission. Another by bombarding the metal with the fast moving electrons. And the third is by making electromagnetic radiation of suitable energy or frequency to fall on the metal surface, that is called photoelectric emission. So in Hertz's experiment, it was observed that if ultraviolet radiations are made to fall, then the spark is bright, and if they are filtered out, then the spark is dim. And this was a problem which no one was able to resolve at that time. So some kind of negative particle is emitted. So it was stated. Now this experiment, Lenard's Halavach experiment, this clearly establishes what? Here we have got a zinc plate. We make ultraviolet light to fall on it. Electrons are emitted. Negative charge particles are emitted. So positive charge is acquired by the plate. At that time, electron was not conceptualized. So what they thought, something negative comes out of this zinc plate because it acquires positive charge. From where does we know that this acquires positive charge? So this was electroscope. So there was divergence in the foils of electroscope. So that's why what we thought is, zinc plate acquires positive charge. The zinc plate becomes more positively charged if initially positively charged, and if negatively charged, it will become neutral. So when it is exposed to ultraviolet light, and note down, photoelectric effect is caused by ultraviolet light. So if you remember this fact, it may be useful for you. Now another was Lenard's observation. So above was Halavach's observation, and Lenard used a very good apparatus. In fact, that is very much near to the next apparatus that we shall be studying. Here, ultraviolet light is made to fall on a cathode, which is which is made up of a metal, and anode is given positive charge. Electrons are accelerated, and this current is measured by ammeter. So battery, here we have got a battery. So what is important is note down this fact that the current is in microamperes. So in photoelectric effect, current is in microamperes. You should be a bit aware about the units, because sometimes even asking questions is a difficult task. Sometimes the choices which are given, if you just look at the units, you can conclude which choice is correct. Threshold frequency is the minimum frequency of incident radiation required to emit the electrons from an emitter. And next, I shall focus on experimental study. Experimental study of photoelectric effect. So here I have got experimental setup. Let us focus on experimental setup. I want to enlarge the diagram. So this is experimental study of photoelectric effect. Light of suitable frequencies made to fall on. This is photosensitive material. Here I have got photosensitive material on cathode. This is source of light. Light comes in here. Here we have got quartz filter, and electrons are emitted. And anode is given positive charge with respect to the cathode, and positive potential. The potential of anode can be varied by making use of potential divider arrangement. Note down the potential divider arrangement. Here is voltmeter, which measures the voltage, and it is always in parallel. We all of know this fact. And here we have got a resistance and a battery attached to it. Now we have got two sliding. Here we have got two sliding wires, so that we can separate, we can move one, or we can move the both, as the situation may be. So now what is the potential difference that is applied is between these 2 points. Potential difference applied to the cathode, so to the anode and cathode, is between these 2 points. So if we increase the distance between these 2 points, then the potential will increase. And now this is the evacuated glass. Glass has been evacuated so as to avoid collisions between electron and air. So once again, this is the source. This is quartz filter, cathode, on which we have plated photosensitive material, anode, which is used to collect the electrons, and there is a potential difference between cathode and anode, and that potential difference can be varied so that we can make experimental studies. Again, notice this fact that the current is measured in microamperes. Note down this fact. The current is measured in microamperes. Current is measured in microamperes. I will directly write 10 raised to power minus 6 amperes. So this current is very small. Now, I will explain you the process. Once electrons are made to, light is made to fall on this cathode, if light is of suitable frequency and energy. Suitable frequency and energy means that the threshold frequency is larger than threshold frequency. We will just give the concept of threshold frequency. I have already explained to you. I will write it nu t. And if I will write it nu t. So if nu frequency of the incident radiation nu I is more than nu threshold, then electrons will be emitted. Electrons will be collected by anode, which is positively charged with respect to cathode. It has got positive potential. This is voltmeter and this is the potential divider arrangement. Again, I am repeating that we can apply different values of potential difference between C and A by making use of potential divider arrangement. This is microammeter, which is used to measure the current. So this is the formal theory written. Electrons are emitted by the cathode, collected by anode. Potential divider arrangement supplies potential to anode and cathode. Voltmeter measures potential difference, and monochromatic radiation of suitable frequency or wavelength is made to fall on the plate and is made to fall on the cathode, and electrons are collected at the plate. As a result, photocurrent flows, which is in microammeter. Now we will make experimental studies. First by varying intensity, then by varying potential difference between plate C, that is cathode and anode, then varying frequency of radiation, and then nature of material of the plate. Now, this is the first case. Effect of intensity of light on photoelectric effect, quite clear. So as we will increase the intensity, so intensity is measured in numbers of photon falling. First I will define intensity I. I will write here. More intensity means more photons falling. If more photons fall, and also you should be aware of the fact that photoelectric effect is all or nothing phenomena. All or nothing means, first I will write intensity I. Intensity I is number of photons per unit area per unit time. Now if I goes up, it means number of photons which I am representing by E. E is the energy of a photon given by h nu according to Planck's law. So this number n. So for further, I will write this as n divided by A into time. Now if I goes up, then number of photon goes up. Now I have just stated that photoelectric effect is all or nothing process. What does this mean? A photon cannot be shared between two electrons. जिस तरह आ ਸਾਡੇ ਕੋਲੇ, for example, suppose this is the electron and radiation falls on it like this. So what will happen? Either it will absorb whole of photon or not. Either it will absorb whole of photon or not. So this is all or nothing. Either one complete photon or it will not absorb the photon at all. Photoelectric effect. In photoelectric effect, interaction between radiation and electron is all or nothing. Simple language. No sharing of photon. By electrons. So in this case, photons are not shared. In this case, photons, they are not shared. So what is important is simply more the number of photons, more electron will be emitted. So probably more electron will be collected at anode. So it means in photocurrent will increase. Once again, listen the logic. If we increase the intensity, we increase the number of photons falling on the metal. So more electrons will be emitted. First, if more electrons are emitted, so it means more and more electrons will be collected at anode. It means photocurrent will increase. So the relationship is linear one. It is described by a line. If we increase the intensity, photocurrent increases. Now, effect of potential. Now, in this case, we will vary potential and keep intensity constant. Intensity and frequency, that will be kept constant, and only potential will be varied. So first of all, I will conveniently write here that I and V. In fact, I should write here nu. I and nu. They are constant. I stands for intensity and nu stands for frequency. So both of them, I and nu, again listen, I stands for intensity, nu stands for frequency. Both of them are kept constant. So in these graphs that I will teach you now, kindly be careful to note down what is constant and what is not. So this is constant. And then what is varied? Potential difference. I have written it with PD and I am symbolizing it with V. Potential difference, this varies. We will make it negative, then zero, and then positive. Now, for one curve, we have kept intensity constant. So, minus V naught is negative potential. Here, anode is put at negative potential. I will go to the above diagram to explain this thing. So here I have got negative potential. Here. Now what will happen? The electrons which will be emitted here, they will be repelled by anode. Only a few very fast electrons will be able to overcome the anode and will be able to reach the anode. If we make potential at anode more and more negative, note down I am using word negative. If we make the potential at anode more and more negative with respect to cathode, then the number of electrons reaching anode will go on decreasing. At a particular point, Even the fastest moving electron will not be able to reach the anode. Or in other words, at a particular negative value of potential, no electron will reach anode. If no electron reaches anode means photocurrent will be zero. That potential is known as a stopping potential. Stopping potential means stopping potential is that negative value of potential difference between cathode and anode such that even the fastest moving electron fails to reach the anode. Means negative potential is measure of kinetic energy of fastest moving electron and photocurrent corresponding to that is zero. Corresponding to what? Corresponding to stopping potential. Stopping potential means it is a negative value of the potential at which photocurrent becomes zero. Simple language. Detailed. Even when the fastest moving electron from the cathode fails to reach the anode, it means electric potential is measure of the kinetic energy of the fastest moving electron. So this is another fact that comes out of it. Now let us see what is given in the graph corresponding to it. So this is the graph. Note it down. This is a stopping potential. This is the potential at which the photocurrent is zero, or in other words, even the fastest moving electron fails to reach the anode, or the photocurrent is zero. So if we multiply it with EV naught, now here I will write, if V naught is the stopping potential, then the kinetic energy of fastest moving electron or maximum kinetic energy of electron K max is EV naught. You just multiply it with the value of electron, then electronic charge, then we will get maximum kinetic energy. This is the significance of stopping potential. Stopping potential measures maximum kinetic energy of the emitted electron. Now let us move further. From here, I kept on making the value lesser negative and towards zero. Photocurrent increases slowly. When the value of anode is made positive, so now anode attracts the electron, so more and more electron will be able to reach. At a particular value of potential, whole of the electrons emitted will reach the anode and photocurrent will saturate. Saturate means if we further increase the value of potential, then photocurrent will not increase. Now, in second case, if the intensity is I2, the graph will be like this. If intensity is more, then saturation current will increase. The basic shape of the graph will remain the same. You can observe from here. So I1, I2, I3. These are three different intensities and the saturation value corresponding to these three different intensities can be measured like this. Is the saturation for I2, saturation photocurrent for I2 and saturation photocurrent for I3. This is the saturation photocurrent for I1. This is the saturation photocurrent for I1. So these are the values of Saturation current. This is I1, small I2 and I3. Now, with these words, I will finish today's lecture and request you to kindly view this video, and if there is something to be improved in this video, then just comment, or if you like it, then kindly share it. So with these words, I finish today's lecture, and we will upload the next video tomorrow. Thank you very much for being with me, and kindly cooperate and comment. Even if comments are negative, though those are important for us. If they are positive, that will encourage us to serve you more in a good manner.